Welcome back everybody to another video, and in this video today we'll be going over SAT Test 10 Section 3. So for our first problem we have 2z plus 1 equals z. So we would want to move our z over to the other side so we can isolate our variable. And when we move the z over, we would get the 1 on the other side, which will become negative 1. So 2z minus z is z, and that equals negative 1. So our answer is going to be B. And question 2. A television with a price of $300 is to be purchased with an initial payment of $60 and weekly payments of $30. Which of the following equations can be used to find the number of weekly payments W required to complete the purchase, assuming there are no taxes or fees? So we know our total is 300. So we can set the equation equal to 300. And we know we're going to be initially paying $60, so we can add $60 on the other side of the equation. And over here it says weekly payments of $30. So each week is represented by the variable W. So we would do 30 for each week and then the number of weeks. So it would be 30W plus 60 equals 300. And the only answer with that as an option choice is C. Number 3. The table above shows shipping charges for an online retailer that sells sporting goods. There's a linear relationship between the shipping charge and the weight of the merchandise. Which function can be used to determine the total shipping charge in dollars for an order of merchandise with a weight of X pounds? So first we have to notice that this is our X value and the total price is our f of X value. So our first step of solving this, I usually start at the very bottom and I just plug in all the numbers. So 40 and 51. So this answer doesn't really make sense because 40 times around 3 is 120. So that one would be too big. This one is too big as well. And 40 times 1 over here for number 1, that would be just 40. And we're looking for 51 as an answer. So if we add around 11, we would get our answer of B, which is also 51.59. For question 4, the line in the xy plane above represents a relationship between the height in feet and the base diameter in feet for cylindrical Doric columns in ancient Greek architecture. How much greater is the height of a Doric column that has a base of 5 feet than the height of a Doric column that has a base diameter of 2 feet? So our base diameter over here is 35 for number 5. And it has a base diameter of 35. And for our 2 feet, it would be 2 right here, so 14. So 14. And then we subtract these numbers to find the difference, or how much greater it was. So that would be 21. And if we look at our answers, it's not 7, it's not 14, and C is 21. For number 5, if x is greater than 0, which of the following is equivalent to the given expression? So first we have to know our square root rules. So we can basically split it up and then square root of 9 times square root of x squared. And square root of 9 is basically 3 times the square root of x squared. These two just cancel out. That would be 3 times x, and that would give us 3x. So our final answer would be A.